Question number 5 says that find the value of the division given in each of the bits. We'll be starting with the first bit where we have 7, which is to be divided by 3.5. Now we can write it as 7 to be divided by 35 over 10. Now we can write 7 divided by 35 over 10 as a product if we reciprocal 35 over 10. So we write 7 as it is. Division is replaced with a multiplication sign, and 35 over 10's reciprocal is 10 over 35. Now 7 ones are 7, 7 5s are 35, 5 ones are 5, 5 2s are 10. So the answer that we get for 7 divided by 3.5 is 2. Coming to the second bit, we have 36 divided by 0.2. Now 36 can be written as it is, divided by 0.2, which can be written as 2 over 10. So we can write it as 36 multiplied with the reciprocal of 2 by 10, which is 10 by 2. Now 2 times 18 gives us 36. 18 times 10 would give us 180. So the answer for the second bit is 180. Coming to the third bit, we have 3.25, which can be written as 325 divided by 100. This is divided by 0.5, which is 5 by 10. Now this is a division of two fractions. So if we have two fractions in division, let's say a by b whole divided by c by d, we can write it as a product of the fractions a by b and having the reciprocal of the fraction which was there in the denominator. So that will be d by c. Going by the same method, here we will write it 325 divided by 100 multiplied with the reciprocal of 5 by 10, which is 10 by 5. We can cancel out 0 and 0. 325 on division by 5 gives us 65. 65 on division by 10 gives us the final answer as 6.5. So the answer for the third bit is 6.5. Coming to the fourth bit, we have 30.94 divided by 0.7. So it can be written as 3094 divided by 100. This is to be divided by 7 by 10. So we can write it as 3094 divided by 100 multiplied with the reciprocal of 7 by 10, which is 10 by 7. 0 and 0 gets cancelled. 3094 on division by 7 gives us 442, which on division by 10 gives us the final answer as 44.2. Now we'll be moving on to the next set of bits. In the fifth bit, we have 0.5, which can be written as 5 by 10 divided by 0.25, which is 25 by 100. Now this can be written as 5 by 10 multiplied with the reciprocal of 25 by 100, which is 100 by 25. So on simplification, we will get the final answer as 2. Coming to the sixth bit, which is 7.75, that can be written as 775 divided by 100. This is divided by 0.25, which can be written as 25 divided by 100. Now we can write these two as 775 divided by 100 multiplied with 100 over 25. So 100 over 25, and we have 775 divided by 100. 100 and 100 gets cancelled. 775 on division by 25 gives us the final answer as 31. Coming to the seventh bit, where we have 76.5, which can be written as 765 divided by 10 divided by 0.15, which can be written as 15 over 100. We can write it as 765 divided by 10 multiplied with 100 over 15, which is the reciprocal of 15 over 100. Now on simplification, we'll get the final answer as 510 for the seventh bit. Coming to the eighth bit, we have 37.8, which can be written as 378 divided by 10. This is divided by 1.4, which can be written as 14 by 10. Now this can be written as 378 divided by 10. multiplied with the reciprocal of 14 by 10, which is 10 by 14. We can cancel out 10 and 10, and that gives us 378 to be divided by 14, and the answer for that we get is 27. Coming to the last bit of this question, which is the 9th bit, we have 2.73, which can be written as 273 divided by 100. Division can be replaced with the multiplication sign. 1.3 in fraction form is 13 over 10, and its reciprocal would be 10 over 13. On simplification, the final answer that we get for this is 2.1. So this is how we solve this problem.
To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.